We're doing rotation images today, and this is from chapter 5 over transformations. We already did translations, we did reflections. Today we're doing rotation images. Okay, so we have rotation. Is a transformation in which each point of a pre-image is turned through a specific angle around a certain point while maintaining the same distance from that point. What does that mean? So it doesn't matter what you're rotating, you're turning through a specific angle. So my super high-tech device over here, we have this guy, so the point of rotation right there, it's right there. So this doesn't change, that stays there. This is my super duper image that I'm gonna rotate, boop, right there. Okay, and just notice that the point of rotation right there doesn't change, and the distance that the image is being rotated through, that doesn't change either. So boop, see, high tech right there. All right, so we talked about center of rotation. Is a static point. What I mentioned was static is what doesn't change. So that was this point right here that I had my finger on the paper clip, so that wouldn't move. And then angle of rotation. Is the angle through which the pre-image is rotated. Okay, now I'm going to color code some things right here for you. So example, we have the image and we have the path of rotation, which is this guy right here. And then we have the center of rotation is the static point, is the point that doesn't change right there. And then we also have the segments. These are the segments. That's the part of the paper clip. Okay, now we know all the parts of it. So angle formed is the angle of rotation. Each point is same distance from the center of rotation. Again, so my paper clip right here, this is the point. So this point doesn't change. Everything is static. Everything stays the same. Okay? So now when we're rotating the triangle ABC by 90 degrees, if we get clockwise, my other high-tech device right there. So we have triangle ABC rotated 90 degrees clockwise. So clockwise goes this way. Okay? And then we get triangle A prime, B prime, C prime. So it starts right there. Static point, rotates 90 degrees right there. Counterclockwise, that goes the other direction. Center of rotation goes boop, right there. So A double prime, B double prime, C double prime. Easy money. All right. When you don't have anything, when it doesn't say anything, the default is counterclockwise. If it doesn't say anything, this is the default, counterclockwise. On sapling, I think you're going to have a question that you're going to use these steps right here. So you're going to center the protector on center of rotation in line with the vertex. You place mark on desired angle of rotation. You measure the distance from center of rotation and vertex. Align ruler and draw and mark the image vertex and measure the distance from the center of rotation. Boom, right there. Okay. Now, it is possible for you to produce 90 degrees, 180 degrees, 270 degrees rotation using vertex coordinates. So let's say we have point A. Here we go with my other high-tech device right there. We have point A and we have point P. So point A is 2 units to the right of point P. Point P is going to be the center of rotation. Point A is right there. So if you move 90 degrees counterclockwise, instead of being 2 units to the right, it's going to be now 2 units above. So 90 degrees, when it doesn't say anything, it's always counterclockwise. So 2 units from the right. When you rotate, it's going to be 2 units above. And then if you keep going, this is the center of rotation. You rotate another one, that's 180 degrees right there. 2 units to the left, that's 180. And then if you go one more time, that will be 2 units below point P, which is 270 degrees. Now, suppose triangle ABC right here, triangle ABC is rotated 90 degrees around point R. Point R is the center of rotation. That is not the origin, but I'm just going to show you how it works. We're not going to spend a lot of time calculating this unless you're in honors. Okay, so point R is right there. When you go 90 degrees, boop, that's where your triangle ends up at. Okay, so from over here, your triangle is rotating 90 degrees around point R. Point R is the center of rotation right there. Okay, so we have point A. Point A is right here. It's 2 units right, 2 units above, right at 2,5. Point B is 4 units to the right, 1, 2, 3, 4, and then 1 unit up. 4 units right, 1 unit up. So from point B, 6, 4, now we have, after it's been rotated, this is the center of rotation. Point B is now right there. It's 4 units up and 1 unit left. So 4 units up, 1 unit left, and the new coordinate for point B is right there at 1, 7. Last one, we're looking at point C. Point C was 4 units to the right and 1 unit below. So after you rotate, it's still 4 units up and 1 unit right, creating the new coordinate, or C prime right there, 3, 7. So a couple more things you just need to know here is that there are formulas for you to calculate that. I'm going to cover this with honors in a little bit more details. In rotations, image and pre-image are congruent. Congruent means same shape and same size. It's congruent because it didn't change. It's right there. It's still my original triangle. Boop. Right there. All right. And that's all I got for you. And then with the honors, I'm going to go ahead and cover and show you how to use the formula right there.